So today I'm going to be talking about data, more specifically analytics, mining, cognitive computing. And I'm going to start off today with a quote. This is by Geoffrey Moore. He's an author of data. He said, without big data analytics, companies are blind and deaf, wandering out onto the web like deer on a freeway. What he means by this is that companies, corporations, wouldn't really make it. They'd be lost without this new source of data. Something extremely important and vital to companies and individuals. And I thought that was just very interesting. So then in a preview, talk about data analytics, data mining, and cognitive computing. Now, data, quite simply, an individual piece of information, a set of values of qualitative or quantitative variables that also can be measured, collected, and reported and analyzed. So they're really vague definition, but it's something that can be used in a whole array of different areas. Now look at analytics. It's discovery and communication of meaningful patterns of data. This is especially valuable in areas rich with core information. They rely on simultaneous application of stats, computer programming, operations research, and so on. Now, some of the areas that we have for analytics: predictive analytics, enterprise decision management, retail analytics, store assortment, stock keeping units. While some examples: marketing optimization, portfolio analysis, risk analytics, digital analytics, and we're talking about marketing optimization. I thought this was very interesting. Marketing recently evolved from a creative process into a highly data-driven process. It uses analytics to determine the outcomes of campaigns or efforts and to guide decisions for investment and consumer targeting. So looking at that data and seeing where's the trend, and they're using that data to adhere to them. And I thought that was a little interesting that they can use big data. Also digital analytics. Instead of business and technological activities that define, create, collect, verify, or transform digital into reporting, research, analysis, recommendations, and so on. Now the challenges of this has to deal with the massive complex data sets. And you see like the data volume, and it's something that will only increase. So it's definitely a challenge to them in the future. Now, when we look at data mining is a subset of computer science, and it's a computational process studying patterns in large data sets involving AI, machine learning, stats, database systems. Looking at the background, some early methods. This goes back all the way to the 1700s and 1800s. 1700s of Bayes' theorem, 1800s of regression analysis. It was interesting that something like this was thought out hundreds of years ago. Now, there are tons of conferences, computer science conferences on data mining. These can include the DMKD conference, the PAW conference, NLDN conference, and then even the European conference on data mining. So it's something that's really sought after and researched worldly. So the process of the knowledge discovery and databases starts with selection as it goes to pre-processing, transformation, and then you have the data mining, and then last but not least, you have interpretation / evaluation. Notable uses of data mining in its course business, but also what I thought was interesting is that medicine as well. Obviously that's going to be an increased sector, but also science and surveillance as well. The cognitive computing. It makes a new class of problems computable. It addresses complex situations that are characterized by ambiguity and uncertainty. So really, in other words, it handles human kinds of problems. So it's really important that cognitive computing is not taken lightly. So cognizant systems really, they must be adaptive, they must be interactive, they must be iterative and stateful, and also contextual. So for adaptive, they must learn as information changes, and as goals and requirements evolve. They must resolve ambiguity and tolerate unpredictability. While being contextual, we must understand, identify, and extract contextual elements such as meaning, syntax, time, location, appropriate domain, regulations, and so on. Now, this is what I thought was really interesting. The additional use of cognitive computing term also has been used to refer to new hardware and or software that mimics the functioning of the human brain. It's a new type of computing with the goal of more accurate model of how the brain/mind senses. So I thought the comparison was really interesting. But it's also something that, is very real. Really, in conclusion, when you have data, you have data mining, you have analytics, cognitive computing. It's all extremely important. This goes back to really the theme is that all of this is important for companies, not just companies, but individuals, as we don't really realize what's kind of behind the scenes with this, and how all of these things can go together and create this world that's a lot more efficient and almost really surreal. But that's all I have right now. Thanks for listening.